Here are some problems for the section on trigonometric equations involving multiple angles. And it says, find all solutions for theta between 0 degrees and 360 degrees. Verify your answer graphically. I'm just going to do 3 of these problems, and then I use the graphing calculator. Okay, so the first one is sine 2 theta equals the square root of 3 over 2. We know that from the unit circle, and hopefully we have memorized that the square root of 3 over 2, the inverse sine of that, is going to be 60 degrees in the first quadrant, 120 degrees in the second quadrant, and that's actually it. However, notice that here it says 2 theta. That means whatever answer we're going to come up with, we have to divide by 2. Now that also means that while the theta itself is going all the way up to 360 degrees, the 2 theta is going up to double that, 720 degrees, which means we can actually go on. So we have the 60 degrees from the first quadrant, 120 degrees from the second quadrant, and of course in the third quadrant and fourth quadrant, sine would be negative, so there are no solutions there. So we're going to go 360 degrees up, and we come up with this solution for 2 theta. And I should scroll up here so we can see this nicer. There we go, and of course that is 2 theta. Again, the 420 is 360 degrees higher than the 60, and we can see the same thing here. And now we divide by 2, and then these are the permissible solutions between 0 and 360 degrees. All right, next problem. So tangent 2 theta equals -1. The -1 puts us into the second quadrant and to the fourth quadrant. So that would be 135 degrees and 315 degrees, as the reference angle would be 45. And we come up again, not just solutions up to 360, but because it's double the angle, we go all the way up to 720 again for the 2 theta. And that's why we don't only come up with 135, 315 degrees in the first and third quadrant, but again, 360 degrees more, which also puts us in the second and fourth quadrant. I hope I said that a moment ago. And then we divide those numbers by 2, and we come up with these solutions. The inverse cosine of -1 is exactly 180 degrees, so there is no other solutions there. But again, we are able to extend our solutions from 360 degrees to a total of 1080 degrees. So we're going to look for all of these here. And I just noticed I made a mistake on this one here. It's actually 540 degrees. So here's the inverse cosine of -1 is 180, and then 360 degrees more, and then again 360 more. And that, of course, here is 3 theta. And then we divide these solutions by 3, and these are the solutions for theta. So let's check that on the graphing calculator. Here's the first one. This apparently must be from something I did on this calculator previously. It looks like a square wave using Fourier. So let's see, I'm going to get rid of that. There we go. And I'm going to type in, and this may be off screen, sine 2 theta. Of course, here I'm just going to use the x parentheses, and now I'm going to use what I have on the right-hand side and subtract it, which means I'm going to have sine 2 theta minus square root of 3 over 2 equals 0, which means it will plot not just the sine, but the x-intercepts for that particular function, and that should readily give me the solutions of 30, 60, 210, and 240 degrees. So let's see that actually happens. So I'm going to subtract the minus square root of 3 over 2. There you go. I'm going to go to mode to check if I'm actually in degrees, which I'm not. So I'm going to go over here to degrees. Then I'm going to go over to window, and I'm going to go from 0 to 360 degrees, because that's what the directions say. Remember that actually the 2 theta right here means that the 2 theta is all the way is able to go up all the way to 720, the theta itself only to 360. The scale here, I will just choose 30. That seems appropriate given the answers that I have here. And for the y minimum, max, -2, 2, that should be just fine for the sine, cosine, and tangent that I will graph. Okay, I already put the function in here, so I'm going to graph. There it is. And we can already see right here, there's the 30 degrees, 60 degrees, because that's the scale I used, 90, 120, 150, 180, 210 degrees, 240 degrees, exactly the solutions that we have here. And then 360 degrees is over here, and we have these 4 solutions. So the next one, tangent 2 theta. I'm going to try this here. Yep, tangent 2 theta, that worked just fine. Here I have to delete a few things. So now I'm going to add 1, that -1 I added, and I graph. And here we go. And again, if this is 30, 60, 90, then this here sure looks like 67.5. And then we have 90, 120, 150. So this one here looks like 157.5. And then 2 more solutions, which again we can see here. We can also use the calculate function. So let's see where I end up here. There we go. Left bound, sure. Right bound, yes. Guess. I'm too lazy to guess. So there we go, 247.5 degrees, which indeed is one of the solutions. And the cosine here. Okay, so cosine 3x, also plus 1, graph. There we go. Here it just touches. This one does look like 60 degrees with a little bit more resolution. We could see it a little easier. This one definitely looks like 180 degrees. And then we have the 300 degrees, and indeed we have 3 solutions. I had prepared these graphs beforehand, so I can paste them in here, and here they are. There we go. I'm trying to get these finally on the screen here, but you already saw them on my graphing calculator. Next problems. So let's see. So the directions are find all solutions for x between 0 and 2 pi. Use exact values only. This looks obviously like a sum or difference formula. And when we look that up in a table, we came up that the specific one is sine a plus b equals 1/2. And then, of course, that would mean that a is 2x, b is simply 1x. So sine 3x equals 1/2. Take the inverse sine of 1/2, which puts us into the first quadrant at 30 degrees, or in the second quadrant, and in the second quadrant at 150 degrees. And in radians, that would be, of course, pi over 6, that's the 30 degrees, and 5 pi over 6, that's the 150 degrees. And then it would, well, that actually would be it. However, notice that we also have to divide these by 3, so this one is going to come out to pi over 18 actually, and 5 pi over 18. And then again, we can go beyond that. So if we put 360 degrees on the original 30 degrees that I had a moment ago, that would be 13 pi over 6, and again divided by the 3 is actually 13 pi over 18, which is inside the interval from 0 to 2 pi, and that keeps on going. So the other solutions are therefore these here. So this is first and second quadrant, originally inverse sine of 1/2 is 30 degrees, 150 degrees, which we then divide by 3 again, and that's how we come up with 10 degrees. If you look at this here, pi over 18, of course, is 10 degrees. 5 pi over 18 is 50 degrees. Then we're going to be originally, for these two here, 360 degrees more for both of those, which we again divide by 3. And then, actually, this is 720 degrees more for both of these. And I'm sorry that the last one is a little bit off the screen. It's still divided by 18. All right, the other one here. Same thing, except we have now a negative 1/2. There we go. Which means we're going to be in the third and fourth quadrant at 210 degrees and 330 degrees, which in radians is 7 pi over 6 and 11 pi over 6. And then again, we have to divide by that 3 here, and we come up with 7 pi over 18 and 11 pi over 18 for solutions. And then again, when we can keep going 360 degrees up, 720 degrees up, because of that 3 that gives us more solutions. So these are the others. And one more problem. Again, scroll it up, actually. There we go. And the directions are, the formula below gives the relationship between the number of sides and the radius r and the length of each side L in a regular polygon. Find n if L equals r, and I have that in this drawing here, so L equals r, that there is only one choice for this one here, which is a equilateral triangle. And we can guess that that particular polygon is going to come out to a hexagon. But let's apply that. So L equals R. That means if we divide on both sides by R, L over R equals 1 therefore. And that's why on my second line here I have a 1 equals 2 sine 180 degrees over n. Then I'm going to divide the 1 by 2 and turn my equation around. So sine 180 over 10 equals 1/2. Again, the inverse sine of 1/2 is 30 degrees, and then 30 degrees equals this. So the solution is n equals 180 divided by 30, which of course is 6. Hence, the solution only, or for this particular condition, L equals R, the only solution we have is a regular hexagon. And this was the problem section for trigonometric equations involving multiple angles.